The rectangular coordinate plane. The rectangular coordinate plane is made up of two number lines, the x-axis and the y-axis. The x-axis is the horizontal number line. It's basically the same number line you've been using since you began adding and subtracting. As you go out to the left, the numbers get infinitely small. As you go out to the right, infinitely large. Now we're adding a second number line, a vertical number line, we're referred to as the y-axis. In the y-axis, as you go up, the numbers get infinitely large. As you go down, they get infinitely small. These two number lines meet at their zeros at a 90-degree angle, so they are perpendicular lines. The point of intersection at their zeros is called the origin. And these two number lines then divide up a plane, or your paper if you will, into four different parts called quadrants. Quadrant 1 is in the upper right hand region. Quadrant 2, moving counterclockwise, upper left hand. Quadrant 3, and quadrant 4. So in order to plot a point, we use something called an ordered pair. An ordered pair, two numbers in a set of parentheses, separated by a comma. The first number is your x-coordinate, followed by the second number, your y-coordinate. For instance, the origin is simply the point 0, 0. X is equal to 0, y is equal to 0. So to plot some ordered pairs, if you look at example 1, the first pair, the point 5, 3, x is equal to 5, y is equal to 3. So we're going to begin by finding 5 on the x-axis, positive 3 on the y-axis. And just look and see where they meet or intersect. So this would be the point 5, 3, which is obviously in the first quadrant. The ordered pair negative 2, 4, x is equal to negative 2, y is equal to a positive 4, so negative 2 on the x-axis, positive 4 on the y-axis would meet at approximately this point here, which is of course then in the second quadrant. Continue on to point 3, 1, x is equal to 3, y is equal to negative 1, is in the fourth quadrant, and the point 0, 4, x is equal to 0, so we do not go to the left or to the right. Y is equal to a positive 4, which puts us at this point, which is not in any quadrant at all. Points that lie on either the x or y axis do not lie in a point. We'll talk about those points later on. Working backwards, example 2, given these 3 points, we want to approximate or find their ordered pairs. So point A is obviously in the second quadrant. If you go down to the x-axis, that puts us at negative 2. If you go over to the y-axis, it puts us at positive 2. So the ordered pair for A, the point negative 2, positive 2. Do the same thing for B. Begin with x, go straight up to x, it gives us positive 1. Go straight over to the y-axis, negative 4. So B is at the point 1, negative 4. And C, it lies on the x-axis at the value 3, the y-coordinate 0, which once again, if it lies on an axis, it does not lie in any quadrant. We got through working with linear equations with one variable. For instance, 2x plus 1 is equal to 5. We know how to solve an equation like this. It's a linear equation because all the variables have an exponent of 1, and we know typically they have one solution, though it is possible for them to have no solution or infinitely many solutions. Now what we're going to do is add a second variable, a y, into the equation. For instance, 2x plus y is equal to 5. It's still a linear equation because both variables still have an exponent of 1, and this is what we refer to as standard form, the form ax plus by is equal to c. Your x is written first, followed by your y is equal to a constant. Now this is a pretty simple example, so we can find some solutions just by looking at it. Each solution must be an ordered pair, value for x and a value for y. For instance, the point 2, 1. When x is equal to 2, y is equal to 1, the left-hand side equals the right-hand side. 2 times 2 is 4, plus 1 is 5. Another example, 1 and 3, 0 and 5. Negative values will certainly work. Negative 1 and 7, 1/2 and 4. We could keep going and going and going. So there are infinitely many solutions to an equation, a linear equation with two variables. So we certainly can't list them all out on our paper. What we're going to do is graph them. And they're going to graph a line, hence that's why they're called linear equations. So a line obviously is straight. It extends on to infinity in both directions, and is simply made up of infinitely many points. Every single solution to a linear equation will be a point on the line, Likewise, every single point on the line will be a solution to that equation. So continue on. Example 3. Given this linear equation with two variables in standard form, we're simply asked to determine if the point 3, negative 3 is a solution. So substitute the value for x and y into the equation. 4 times 3 minus 3 times negative 3. We want to see if that's equal to 21. So 12 plus 9 is equal to 21, which yes it is. So therefore, yes it is a solution. It checks out. Example 4. Is the point 5, negative 2 a solution to this equation? So we substitute in the values, x and y. See if the left-hand side equals the right-hand side. Negative 5 minus 14 is not equal to negative 9. So therefore, it is not a solution. Most of the time, though, we're going to be asked to find solutions. So example 5, linear equation with two variables in standard form. We want to find some solutions and then plot the points in order to graph the equation, graph the line. In order to do that, we can construct a t-table. It's just a little table made up of two columns. The column on the left are your values for x. The column on the y, your values. The column on the right, values for y. And if we randomly choose a value for x, we can plug it into the equation, and that allows us to solve for y. Since we cannot solve a linear equation with two variables, once we plug in a value for one of them, now it's a linear equation with one variable where we can solve. So y would simply be equal to 2. Choose another value for x. Another value for x might be 0.1. 2 times 1 plus 3y is equal to 6. So 3y is equal to 4. So y is equal to 4/3. So we have another solution to the equation, another point. And as long as we didn't make any mistakes, we only need 2 points to sketch a line, but it's always a good idea to choose the third point. So if we randomly choose another point for x, maybe negative 2, when x is equal to negative 2, plug it into the equation, solve for y. Y works out to be 10/3. So now if we plot these points, all these points obviously should form a line. The point 0, 2, 0.1 and 4/3, and the point negative 2, 10/3, about 10 1/3. So we can see they do form a line, so just sketch the line passing through those points. And example 6. Still a linear equation with two variables, but it's not in standard form. But we can still use this point plotting method. Randomly choose some values for x, at least 3. 0, 2, maybe negative 4 if we randomly choose some. When x is equal to 0, y is equal to negative 1. When x is equal to 2, y is equal to negative 3. And when y is equal to negative 4, y is equal to 9. So plot these points. They should form a line. The point 0, negative 1. Point 2, negative 3. And the point negative 4, positive 9 takes it off our paper a little bit, but we can see it certainly does form a line. Sketch a line is the graph of that equation.